Hello everybody, this is Matthew, and today we're going to be attacking the 2024 AMC8 from 22. The question reads, a roll of tape is 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. So as you can see in this diagram here, this is the roll of tape. 2 inches in diameter, 4 inches in diameter. A cross-section of the tape is shown in the figure below. The tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long will it be? Round your answer to the nearest 100 inches. So the question asks us to find the length of the tape after the whole thing is unrolled. So as you can see here, once the whole tape is unrolled, it will look something like a rectangle, where the width is 0.015 inches because the problem gives us it's 0.015 inches thick. The length is how long the tape is. And notice that we can, since the problem gives us the cross section of the tape, we can also take the cross section of when the tape was unrolled, because the depth or the height is going to be the same in both cases. Like the tape really is supposed to look something like this if we draw it in its 3D form. Like if you can imagine, the tape has some depth, but since the question gives us the cross section, we can simply take the cross section of the rectangular form of the tape as well after it's all unrolled. And this actually simplifies the problem a lot, because now we know the width of 0.015. We know the width of the rectangle. We want to find the length of the rectangle. And to find the length of the rectangle, we can use the formula area of a rectangle is equal to length times width. We have the width, and if we find the area, then we have the length. So now all we got to do is find the area. And the area is pretty easy to find because we have the side lengths or the diameters of both circles. And all you got to do is find the area of this inner, or not the inner circle, but the area of this annulus. And this annulus is basically the area between two circles sharing the same center. So how do we do this? Well, what we can do is find the area of a big circle and then subtract it from the area of a small circle. And that will leave us with the annulus, the area of the annulus. So the area of a circle is equal to pi r squared. The radius is equal to half the diameter because it's the distance from the center to the outside circle. So we have, for the area of the big circle, we have pi times r is equal to 2 squared, so 4 pi. Now the area of the smaller circle, so area of the large circle, now area of the smaller circle, also equal to pi r squared, but the radius is equal to 1 in this case because the diameter is 2, and 2 divided by 2 is 1. So after this, we have the area of the large circle, we have the area of the small circle. So we subtract it to get that the area of the annulus, or the area between the circles, is equal to 4 pi minus pi, which is equal to 3 pi. And we know that it has to be the same as the area of this rectangle because, well, the tape is just being unrolled. The tape isn't changing, so the area should stay the same. So the area is 3 pi. So now we can write it. 3 pi is equal to length times 0.015. Now we move this over to the other side. We get length is equal to 3 pi over 0.015. All right, cool. So now the problem just comes down to approximating what 3 pi over 0.015 is. So what I like to do is first get rid of the decimals. So 0.015, it's equal to 15 divided by, so we have 15 right here. Then we have 1, 2, 3. So 15 divided by 1,000. So now we can rewrite the length as equal to 3 pi over 15 divided by 1,000. And now this is equal to 3,000 pi over 15. And we can cancel this out. We get 200. So we have length is equal to 200 pi. And since we wanted to round it to the nearest 100 inches, we can simply approximate pi as 3. So we get length is equal to 200 times 3, which is equal to 600. So the answer is 600 inches. I hope you guys enjoyed this video. May the force be with you. See you next time.